Well, hello, good Friday evening. For those of you watching, it might not be your Friday, but it's my Friday. Anyway, we're going to simplify complex fractions using method 2. I must admit, I'm kind of partial to method 2, and you might see, if you watch the video for method 1, you'll see that it's a little bit shorter. So method 2 is basically saying, let's get rid of those fractions right off the bat, okay, which is the whole goal of simplifying a complex fraction. Okay, so how we do that is we multiply by the least common denominator of all the fractions so that the denominators will cancel out. Okay, so in this, you notice it's the same example I did in the other video for method 1. Okay, and in my complex fraction, in the numerator, I have one fraction, and in the denominator, I have one fraction. So the idea is I need to come up with the least common denominator of those two fractions and multiply everything on top and everything on bottom by that denominator, least common denominator. So both fractions have a denominator of a, therefore the least common denominator of all the fractions in the rational expression is a. So what I'm going to do then is I'm going to take and multiply everything in the numerator, okay, that's why I'm putting parentheses so I remember, and everything in the denominator by a. I typically like to go ahead and distribute that a and write it next to each term so I don't miss anything. So I've got b over a plus 3b, and then let's see, b plus, leave some space here, b plus 2b over a. So I need to multiply my first fraction by a, and I need to multiply my 3b times a. In the denominator, I need to multiply the b times a and that fraction times a. Okay? So it's like we're multiplying fractions. So you can think of that a as a over 1 at least in the fraction situations. I don't really need it in the other places. All right, so what happens here? When I'm multiplying fractions, remember the idea is to divide out common factors. So the a cancels out or divides out, and we're left with b times 1 is b over 1, which means I don't have a fraction anymore, and that was the goal, get rid of the fractions. Here I don't really need the 1, so it's 3b times a. I always go alphabetical order, 3ab. Doesn't matter though. All right, in the denominator, when I multiply b times a, I get ba or ab. And the second one, I'm multiplying fractions. The idea, remember, is to divide out the common factor of a. Notice how my denominator cancels out to be a 1. So I basically have 2b times 1 or 2b. Now look at that. Basically 2 steps there, and we're to a rational expression. All we have to do is see if we can simplify. Remember, to simplify fractions, you get rid of common factors in the numerator and denominator. So this rational expression is a factor, but I cannot cancel out any factors until it's factored. Okay, don't be tempted here. You have to factor first. Okay, this is not factored because of the pluses. All right, so in the numerator, these 2 terms have a common factor of b. So I factor out the b, and I end up with 1 plus 3a. And in the denominator, those 2 terms also have a common factor of b. So I divide out the b or factor out the b, and we're left with a plus 2. So numerator and denominator have a common factor of b. So I'm going to divide the b out of the top and bottom, and I'm left with 1 plus 3a over a plus 2. Simplified answer there. Okay? Same as I got in the last video for those of you who watched it. All right, let's do the second example. Notice that in my complex fraction in the numerator, I have 2 fractions. In the denominator, I have 2 fractions. Okay? So ultimately, I have 4 fractions. So what we need to come up with is the least common denominator of all 4 of those. Okay? So remember, the least common denominator is the product of every different factor that occurs in any denominator, the most number of times it occurs. Okay? So in the top, I have a denominator of x, and it occurs once here. And then here I have a denominator of x squared, which means I have 2 factors of x there. So remember, it's the most number of times it occurs in any denominator. So my least common denominator has to have 2 factors of x, or x squared. Similar situation with the y's. I have 1 factor of y here, but in the denominator I have 2 factors of y. So in the least common denominator, it's the most number of times that the factor occurs in any denominator. So my least common denominator is x squared, y squared. Okay? So I'm going to take both terms, or excuse me, both fractions on top and multiply by x squared, y squared, and both fractions on the bottom, taking the entire numerator and denominator times x squared, y squared. Okay, so I'm going to go ahead and distribute that, or excuse me, rewrite that, and then I'll do the multiplying. Okay, so I'm going to take 1 over x times x squared, y squared, and 1 over y times the common denominator of x squared, y squared, and same thing in the denominator with those 2 fractions. And remember, the goal is the denominator should divide out or cancel out so that we have a denominator of 1, which means we don't have any more fractions. Okay? So here, when we go to multiply, we can put that over 1, we see that the denominator, or see that we have a common factor, so we're going to divide that out, divide out an x. So we're left with 1 times x times y squared, which is xy squared. And in the denominator, there's a 1, so there's no fraction. Okay? Once again here, divide out common factors. I have a common factor of y, so I'm going to divide a y out from each of those, and I'm left with minus 1 times x squared times y. So it would be minus 1x squared y. And the denominator is 1, so no longer fraction. And we'll go the same thing into the numerator of my complex, what was my complex fraction, it's not going to be complex much longer. All right, put this over 1. If I divide out common factors of y squared, I'm left with 1x squared, or x squared. And here, I'm going to divide out my common factor of x squared, and we're left with minus 1 times y squared, or minus 1 y squared. Nice, rational expression. All I have to do is simplify if possible. Remember, simplifying rational expressions is like simplifying fractions. Get rid of any common factors, but before you can do any canceling, you must factor first if possible. So in the numerator, my 2 terms have a common factor of x, 1 factor of x, and a common factor of y. So I'm going to divide both terms by xy. So we're left with y minus x. And in the denominator, we've seen this before, x squared minus y squared is a difference of 2 perfect squares. Factors into conjugates with different signs. Now it's completely factored. Now I can divide out a common factor. And once again, y minus x is the opposite of x minus y. So we can, technically they're not equal, but if I took y minus x and divided by x minus y, remember we'd have that negative 1. So in the numerator we have negative 1xy over x plus y, which should be the same thing we got using method 1. So pick your method and use it.